This video is on the objective understand and compare confidence intervals in context. And it's number 2, so it's the second video I'm doing on a question related to this objective in your Newton Alta homework. Alright, so I've already done one like this. I'm not going to draw a picture this time. It's very similar, one of these where you're moving these dots around and taking a look at the picture down here of the normal distribution for the x bars for the sample means. And they might have another one where there's sample proportions, right? So they might have p hat, instead of x bar, but it is very similar. So here, the time it takes to manufacture an electronic component for a car are normally distributed with a population standard deviation of 1.3 hours. So this is the sigma, the population standard deviation, right? Sigma. And an unknown population mean, right, mu, and that's what we're trying to guess, right? That's what a confidence interval is. It's a range of guesses as to what the population mean is, or the population proportion, if you're talking about that. All right, so here, if a random sample of 55 electronic components is taken and results in a sample mean of 8.1 hours, this is your point estimate, your x bar. Find a 90% confidence interval for the population mean. All right, so this one I'm just going to go through using the tool because, again, I've drawn a picture before. I would draw a picture for, where the horizontal axis, the number line represents possible values of x bar, right? The sample means for samples of size 55. And then in the middle, you have your sample mean, 8.1. That's our point estimate. And then the standard deviation would be 1.3 divided by the square root of 55, and that'd be the standard deviation. Then you figure out what values to the left and to the right, so that's symmetrical. What's the margin of error, so that you have 90% underneath the curve. So I'm just going to use the tool here, right? So the sample mean x bar, right, we're just sliding that to 8.1, right? 8.1 hours. So sample mean 8.1 hours. Come on. There. Standard. This is sigma. This is not sigma x bar. This is sigma. The population standard deviation that was given to us is 1.3 hours. There we go. And then n, remember what is the sample size? You're pulling samples of 55 electronic components here, so I'm pulling 55. Right, and then the confidence level, is what kind of a confidence interval estimate is being made here, and that was 90%. So I move this dot here to 0.9. And they're giving a critical value. Now we'll talk about critical values in a later section. The critical value here is just how many standard deviations from the middle these upper and lower limits are of the confidence interval. So like this 7.81 here, that's 1.645 standard deviations below the mean, and this 8.388, that's 1.645 standard deviations above the mean to get 90% in between, right? 90% of the area under the curve in between those. That's all this critical values are just like numbers of standard deviations, right? Like a z-score. Don't worry about that right now. All right. Yeah, and they said round your answers to 2 decimal places. So based on this sample, we would say that we are 90% confident that the true average time it takes, the average time it takes for the population to make all these electronic components is somewhere between 7.81 and 8.39 hours, right? Hours. So what we're saying here is that we're 90% confident that the average time it takes to make all the entire population's worth of electronic components is between 7.81 hours and 8.39 hours, and that's all we're entering down here. So after you move the dots to the proper places, enter your lower limit for the confidence interval rounded. Again, pay attention to how many decimal places they want you to round to, 7.81, and then the upper limit, this 8.388, but that would round to 8.39. hours. And submit. And again, if you are correct, read your either way, whether you're right or wrong, please read through, glance through the answer explanation, especially if you're wrong, right? Just to see if you can figure out where things were, where you went wrong, where were you incorrect. And that's it. Right, again, pretty easy one. These just movement slide. Well, what's the sample mean? What's the population standard deviation? What's the sample size? What's the confidence level? And then you get your confidence interval drawn out for you. Right, you don't have to do it yourself. In later sections, of course, we'll have to do it ourselves. And also, of course, be showing you how to do that with a calculator. But for right now, we're just looking at these pictures. All right, so hopefully this helps when you do your own. And thank you very much for watching.